Space is silent. That's what we've always been told. No air, no sound, simple physics, right? But in 2003, NASA detected something impossible. A sound coming from a black hole 250 million light-years away. A note so deep, so unimaginably low, that it shattered everything scientists thought they knew about the cosmos. I'm here to take you on a journey into one of the most mind-bending discoveries in modern astronomy. We're not talking about science fiction or theoretical speculation. These are real sounds, captured by NASA, ESA, and space agencies around the world. Sounds that have left even veteran scientists stunned and questioning what they thought they understood about the universe. Today, we're going to listen to the voice of the cosmos. We'll hear black holes humming, planets whistling, and stars drumming rhythms that have been playing for billions of years. But before we dive into these incredible recordings, we need to address the elephant in the room. How can space have sound when we know it's a vacuum? Every space movie you've ever watched has lied to you. Those dramatic explosions, the roaring starship engines, the whoosh of passing asteroids, none of that would make a sound in real life. Because sound is a mechanical wave. It needs molecules to travel through air, water, solid material, something that vibrates and carries that vibration forward, and space. Space is the ultimate vacuum, near perfect emptiness, no air, no medium, no sound. This is Physics 101. We teach it to kids in middle school. When astronauts work outside the International Space Station, they communicate through radio because their voices can't travel through the void between them, even though they're just meters apart. So when scientists talk about sounds in space, they must be speaking metaphorically, right? Converting data into audio just to make it easier to understand. Not exactly. In 2003, NASA's Chandra X-ray Observatory was studying the Perseus Galaxy Cluster, a massive collection of galaxies bound together by gravity. Sitting 250 million light-years from Earth, scientists were analyzing the hot gas that fills the space between these galaxies. When they noticed something strange, ripples, waves of pressure moving through the gas. And these weren't random fluctuations. They were periodic, rhythmic, spreading outward from the cluster's central supermassive black hole. They were sound waves. The black hole was singing. But here's where it gets truly mind-blowing. The note this black hole was producing is the deepest sound ever detected in the universe. It's a B-flat, but 57 octaves below middle C. That's more than 1,000,000 billion times deeper than the lowest frequency the human ear can detect. To put that in perspective, the lowest note on a piano is already about 7 octaves below middle C. This cosmic note goes 50 octaves deeper than that. If you wanted to hear it naturally, you'd need a piano keyboard stretching across multiple galaxies. NASA scientists took this impossibly deep frequency and pitch-shifted it up 57 octaves so human ears could perceive it. And this is what it sounds like. The sound you're hearing traveled through intergalactic gas for hundreds of thousands of years before we detected it. But how is this possible? How can sound exist in space? The answer changes everything. Space isn't completely empty. Between galaxies, there's gas. Extremely thin, almost nothing, but it's there. And when supermassive black holes pulse with energy, they create pressure waves in this gas. Real, physical sound waves that propagate for millions of years across cosmic distances. We just needed the right instruments to detect them. And once scientists knew what to listen for, they found sounds everywhere. Jupiter, for instance, produces some of the most haunting sounds in our solar system. The giant planet's powerful magnetic field interacts with charged particles, creating radio emissions that can be converted directly into audio. Scientists call these phenomena whistlers and chorus, and they sound genuinely alien, eerie, otherworldly, like something from a science fiction horror film. These aren't artistic interpretations. This is what Jupiter actually sounds like. Then there's the Voyager spacecraft. When Voyager 1 crossed into interstellar space in 2012, it detected something unexpected, a persistent hum, the vibration of interstellar gas itself, excited by distant cosmic rays. It's the ambient sound of the space between stars, a drone that has been playing since long before Earth existed. And perhaps most fascinating are pulsars. These rapidly spinning neutron stars emit beams of radiation that sweep past Earth like cosmic lighthouses. When converted to audio, they create rhythmic pulses, precise as metronomes. In fact, when British astronomer Jocelyn Bell first discovered them in 1967, the signals were so regular that scientists briefly wondered if they were artificial, evidence of alien technology. They weren't, but they sound just as extraordinary. These sounds aren't just fascinating curiosities, they're scientific instruments. By listening to space, astronomers can map invisible structures that telescopes can't see. Sound waves reveal the distribution of gas between galaxies, helping us understand how the universe evolved. The frequency and rhythm of these cosmic sounds tell us about extreme physics conditions we can never recreate in laboratories on Earth. Black hole acoustics reveal their mass and spin. Pulsar timing helps us detect gravitational waves. Jupiter's radio emissions warn us about dangerous radiation storms that could affect spacecraft and satellites. But beyond the practical science, there's something profoundly moving about this discovery. For thousands of years, humanity looked up at the stars in reverent silence. We thought the cosmos was a soundless void, beautiful but mute. Now we know better. The universe has been speaking all along. It's been singing, humming, drumming its existence into the fabric of space itself. We just didn't know how to listen. And this is just the beginning. The James Webb Space Telescope is now equipped with even more sensitive instruments capable of detecting fainter cosmic phenomena. Gravitational wave detectors like LIGO and Virgo are literally hearing the collisions of black holes and neutron stars, events that create ripples in space-time itself. We're entering an era of multisensory astronomy, where we don't just see the universe, we hear it, feel its vibrations, decode its rhythms. Every new telescope, every new detector brings us closer to understanding the cosmic symphony that's been playing since the Big Bang. What will we hear next? What sounds are still waiting to be discovered? So the next time you look up at the night sky, remember this: it's not silent out there. Black holes are humming bass notes that span galaxies. Planets are whistling through magnetic storms. Pulsars are drumming precise rhythms across light years. The universe is performing a symphony that's been playing for 13.8 billion years, and we've only just learned to hear the first few notes. If this changed how you see the cosmos, hit that like button, subscribe for more mind-bending space discoveries, and drop a comment. Which space sound surprised you most? The universe is calling. Let's keep listening.